Okay, we're going to go ahead and get started now. All right, so while I've got you seated, I'm assuming most of you guys have at least played with Kubernetes to some extent. Is that true? Has anybody here who has not at least played with Kubernetes at all? Okay, one person. Okay. I'll try to touch on some key points when necessary. All right, so I'm Doug Davis, IBMer, operating manager for Knative, and basically I'm going to give you an introduction to, obviously, Knative. A little bit of history. I'm going to explain why we're at the stage we're at, how we got here, why Knative might be useful, and why it's a very timely development in the industry. Then do a demo. Most of the stuff is 100% factual. There's a little bit of sprinkling of my opinion in here, to figure out when that is. So take a little bit of what I say with a grain of salt. Not too much, still though. But maybe the history lesson. We'll see. Okay, so when Docker or containers first started, we had Docker. Everything was wonderful, right? You had this simple little command line, Docker run, you went to the hello world. And, oh, I guess I should say, if you have questions, don't hesitate to raise your hand and stop me. I know I talk fast. You know I'm trying to actually slow down, believe it or not. But if you rate and ask questions, that will force me to slow down. So ask as you go along, it's fine. So anyway, you have Docker run, you run to hello world, print out hello world. Great. And it's a very simple world. It was easy to understand things, right? You had containers, you had Docker build, you had images, and you had Docker hub to share those images. Life was relatively easy and good. Very simple, straightforward. Okay? After that, we then started adding things like networks, volumes, services, Docker Swarm to manage these things. And these were necessary because as you started getting a little more mature with what you wanted to do, you need a little bit more control and enterprise type things associated with it, right? Containers are great, but you need persistent storage, right? You need them to talk to one another. All these things started coming into play. So things got a little more complicated, but still not too bad. I mean, these are all basic concepts that all of us as computer programmers are used to to some extent, so it still wasn't that bad of a world for us. However, not everybody was perfectly happy with Docker. So Kubernetes kind of came along, and you get this wonderful little C-suite definition of what Kubernetes is. And I look at that, and it just goes right over my head. It's way too complicated, just from a definition point of view. So what is Kubernetes? Obviously, most of you, except over here, knows Kubernetes is for managing containers. And that's great, right? As a developer, you were told, use Kubernetes, deploy it, it's going to make your life easy, it's going to scale it for you when you tell it to scale, and everything's going to be wonderful. Well, unfortunately, as most of you hopefully realize, it's not quite that simple, right? You got all of this crap to deal with, right? It's not just, oh, deploy your container anymore, oh, you may have a network or volume. You got all of this stuff involved that you have now to manage. And the point here is, all the complexities of the entire networking or computing world that Docker was hiding from you, now it's been exposed to you all over again, and you were told it was simple, right? It was wonderful. We were making a little bit of fun of YAML before. Well, now you got YAML out the wazoo, right? And it's supposed to be wonderful, like it's perfect. Add on to the basics, things like blue-green deployments for actually managing these things as you migrate your applications. And life is not easy. You have to become this IT guy to understand it all. And it was very frustrating to me anyway to hear everybody talk about how wonderful it is. It's great, it's simple, it's wonderful. I love it better than Docker. And I was always convinced these guys were looking at it from like an IBM researcher perspective, right? The more complex, the better it must be, right? I look at this and say, oh my gosh, help me, right? I miss Docker, okay? I can appreciate all the functionality Kubernetes gave me, but this was not easy to me, okay? So you have all that sort of lingering out there. And so back to first principles. Well, when I first was introduced to Kubernetes, I was told Kubernetes is not a platform for actually hosting your application. It is a platform to build platforms. And I thought, okay, well that's great. Well, where are those other platforms? Because I don't like Kubernetes, it's too complicated. Well, it became the platform. You guys all know that, right? You work directly on Kubernetes directly, and whether you like it or not, you got to deal with the YAML, Helm files, all the other stuff, and your life is miserable if all you want to do is deploy your application. Now, imagine, how many of you guys know Cloud Foundry and use it, or have used it at least once? Okay, fair number of you. So you know what a good user experience is supposed to be, whether it's Cloud Foundry, Docker, maybe simplistic in some cases, but at least it's a nice user experience. That's what I think most developers would like to have, at least for the basic stuff, right? They understand that there are some complex scenarios where you have to go to the covers, But for a significant portion of the time, all I want to do is run my application, right? There's all this infrastructure there for me. It's supposed to be hiding it. Cloud is about abstraction. Where did all that go? Gone out the window, okay? So you got all of that there. Now, enter stage left, serverless. Now, with Kubernetes and containers, you see this sort of progression where you go from bare metal to virtual machines to containers, where the level of abstraction is increasing for you, meaning you have to manage less and less of the infrastructure for a whole bunch of reasons. Things like you want the system to manage it for you, right? So you don't have to manage physical machines anymore. Virtual machines are good enough for you, just manage the operating system. Well, I don't want to deal with the operating system. All I want is my code. Containers are good for that, right? So you get this level of abstraction, things are moving away from you, that's all goodness. You can squeeze more things into these resources, better resource utilization, saving time and money, or time, at least money. And that's all good, right? Serverless takes you to the next level. Rather than just containerizing your application, you're not just containerizing little bits of code, meaning functions. So you can kind of think of it as, a whole bunch of class library kind of things, right? Just little functions out there, utility functions to get your job done, one single purpose type things. In a perfect world, these things would scale up and down automatically for you as you start calling them. Again, managing the infrastructure for you is what serverless is really all about. So it takes everything to the next level. So just to reiterate some of the points of serverless, right? They're supposed to be stateless, like most containers are supposed to be. And that doesn't mean you can't not volume stuff into them, but the code itself should assume it's going to die any second, at least when it's done running. Typically event-driven, meaning they typically run in response to something happening, whether it's some sort of HTTP request coming in, timer, something else, doesn't matter. That's an event. Auto-scale. Most serverless systems will scale up automatically based upon the load into your function. Most importantly, though, for a true serverless system, it needs to scale down to 0. Meaning when it's not being used, it's not even running at all. So you get the benefit of cost savings. So you're not going to get charged if your function is never actually invoked. A lot of people like that aspect. Short-lived, these things are not typically supposed to live on forever. I actually think that it's more of an artifact of the way providers choose to expose this to you. There's nothing about the technology that says a serverless function couldn't run for years as long as the system stays up. I think a lot of people just do that because they want these things to be short-lived so that they can provision them quickly and stuff like that and move them around. So I think it's more of a factor of the platform itself. Again, this is all to reduce the cost. Ultimately, though, it's to get the developer to produce his code so it can go out to the market faster so that they can get their product out there to their customers, make more money, and oh my gosh, I apologize. There was something right in my head I just completely left my mind. Faster time to market. Oh, yeah, so it's about also making the developer get back to what they really want to do, which is just code and not manage infrastructure, right? So you got serverless world, trying to make life easy for people. You got Kubernetes, not so easy, okay? So Knative actually tries to bring those two worlds together. It says, why can't we have the simplicity of something like serverless, or even Cloud Foundry to some extent, for those of you who've heard Cloud Foundry, but offer it up on top of Kubernetes. And that's really what Knative is all about. And you can ignore that definition, it's a little bit complicated for me. But what it really means to me is, it's an opinionated view of application management. Really what it means is an opinionated view of Kubernetes. So what Knative does is it says, here's all the wonderful features of Kubernetes, but we're going to have an opinionated view, dumb it down for you in essence, give you a limited functionality in the sense that we're not going to say expose all the bits and bytes to you, but we're going to add some of the features that you get from serverless, things like auto-scaling and stuff like that. Things you could technically get from Kubernetes if you knew how to manage it yourself. And that's a huge if, because who actually wants to deal with all that stuff? No one wants to, right? We have these computers, they should be smart enough to do it for us, right? And again, it's all for getting the developer back to what they want to do, which is code. Now, for those of you who understand Kubernetes enough, what this really means is extending Kubernetes with custom resource definitions. So it's just extending the Kubernetes model with some other things that sit on top. So again, it's not rewriting Kubernetes, it's leveraging Kubernetes. That's a very key point. All right, so what is Knative under the covers? Knative actually consists of 3 different components: build, serving, and eventing. And I'll go through each one. Let's start with build. So build is basically the notion of, give me your source code, I'll put it into a container for you, and then I'll pass it on to the next sprint, to the next stage, which is typically serving. But for those of you familiar with typical serverless frameworks or Cloud Foundry, this should be very familiar to you. Because a lot of those do take source code, whether it's just a snippet of code, or you point it to a GitHub repo. Same concept here. In fact, Build templates are basically the exact same thing as Cloud Foundry's build packs. I think they're called build packs, right? Where they basically do the same thing. Give us your source code, we'll figure out the right compiler for you to compile it, and then upload it to the system so now you can run it. So they have this built into Knative itself, and that's something you get from Kubernetes today. Serving. This is pretty much the guts of Knative, as you might imagine, because it's set on top of Kubernetes. And it really consists of four main objects. First is the service, which is basically your application. Think of nothing more than that. And it's just a wrapper for these other concepts. Next, you have configuration, which is really nothing more than a list of pointers to revisions. And you can think of revisions as versions of your application. So really, it's these revisions that matter most. That's basically, think of it as your configuration file that says what container to run, what configuration properties to give it, memory, CPU, that kind of stuff, that environment variables. Same kind of things you might think, or you might see with a normal pod YAML file for Kubernetes, or for Docker, your Docker run command parameters and stuff. So you have different versions of your application running. And then you have route. Now route does automatic traffic routing for you, basically. So in this particular case, I set up a route that said route 90% of the incoming traffic to my service to revision 2, but 10% to revision 3. So I can start doing A/B testing, or whatever kind of testing methodology you want to call it. But basically, it's allowing me to tell Knative or Kubernetes how to route the traffic automatically. I'll do my testing, slowly change the percentages over time. I don't have to manage that anymore for me. I just sort of give it those percentages, and magic happens in the covers. Okay? So, moving forward, just to sort of encapsulate what I said there. So there's build as part of the service definition now. So your one YAML file can describe not just how to run your application, but actually how to build it. You can, through that same YAML file, describe rolling updates, so A/B testing type stuff. And again, this is all for better resource utilization, so you're going to get those serverless properties, right? Scale down to 0, auto-scaling on demand based upon the events coming in. And it will manage all the Kubernetes resources under the covers that it's using to accomplish all this. So you don't ever actually technically have to deal with pods, deployments, replica sets, ingress, all that stuff, you don't have to worry about. Okay? And I guess I should say, that this is kind of ironic to me. When I first joined Knative, it was advertised to me as not a serverless platform, not a platform as a service platform, but it is a platform to build a platform as a platform, or a serverless platform. Again, the exact same story I was told with Kubernetes, right? It's not going to be a platform, there's going to be something else on top of it. As of right now, Knative is a platform, right? Whether something else comes later, I don't know, but be prepared. If you want to play with Knative, there's nothing else on top of it really yet. Mainly, this is the platform you want to use it, which is fine, because I actually think it's simple enough. It actually does bring you back closer to the Docker world or kind of Foundry world. Now, Knative serving, as well as other components in Knative, are still, I think what we got, 0.5 release. So changes are being made. And so some of the stuff I'm going to describe here, while feature-wise is still true today and will still be true going forward, you can expect some of these things to change even in the latest version in terms of like what the YAML looks like and stuff like that. And I'll try my best to point out some of those as we go forward. But just keep in mind, if you look at this and then go home and start playing with Knative and see some differences, that's why, because things are changing rapidly. But conceptually, the features are still basically there. It's just the syntax in most cases will change, or have changed slightly. And finally, the last component, eventing. So eventing is basically going to provide you the base infrastructure. Oh, sorry.
Yeah. So we talk about those features. So what do you do? And you also said those Knative is built on top of Kubernetes. So what are they in terms of like Kubernetes?
What are the Kubernetes resources it's using under the covers?
Right. So to provide those services.
Right. Actually, what's funny is that when I do the demo, I was actually going to show you all the resources that get created. But just for quick, let's see. So the revisions basically become deployments. Okay. So as I have 3 different versions of my application, I get 3 different deployments. Each one can scale independently. That's why each one's a deployment. Route configuration, those are new. I'm trying to think what else. It leverages ingress and Kubernetes services under the covers for networking type stuff. There's the pod autoscaler. That's in there under the covers as well. Obviously pods, whatever. I think those are the main ones. You'll see the list when I run the demo, but those are the main ones. And I guess I should point out service. This is a Knative service, not a Kubernetes service. Different, unfortunate that they have the same name, but it is a different concept. Okay? Any other questions? Yes, sir.
So I think the last time I heard at Knative talk, every time I think about serverless, I think about the latency issue. And the way people work with serverless is they call a URL, basically, and they're invoking it. So the back end has to run the serverless code to run that snippet of code to do that process. And the issue is, how do you get that into a VM or a container or a, raw hardware or whatever you're going to run it on, in the most efficient manner, and get the latency down so that the RESTful API gets executed in a reasonable amount of time instead of an unreasonable amount of time. So how does Knative resolve that problem or work on that problem? And to me, that's the big issue, because there's a lot of serverless out there, and people are even, I think, I'm not sure whether Azure is or AWS is actually giving away private implementations where you can install their software and run your own private cloud and run serverless on it and things like that. So there are alternatives, and the question is, where are you getting an efficiency over this?
Right, okay, so basically you're asking about how does Knative deal with the cold start time?
Yeah.
Your function has been scaled down to 0, first request comes in.
First pod, while you're running a pod.
And as I'm sure most of you play with Kubernetes, Kubernetes is not the fastest thing in the world when it comes to spinning up pods, right? It's a very asynchronous model. That is a huge issue for at least some of us in the Knative community. IBM in particular is working very hard to try to fix that. I believe right now we could probably get it down to somewhere in the 2 to 3 second range for spinning up that first one. We are working on getting it better because we want it to be as fast as OpenWhisk, which is like millisecond kind of a time.
Yeah,
right?
open.
And we are looking at lots of things to make that happen. We're just not there yet. It is a very big concern to us, and we are working on it.
And is IBM, I mean, if you look on the web, Google and this other company are the big Knative people, and IBM is just like a minor player or whatever. Is that not true? Is IBM? Oh yeah, it should not. Exactly. I'm a former IBM.
In 6 months, that might change.
Okay.
No, actually, no. IBM is there, but in all honesty, there are other companies that have more people there. But we are definitely there. So we are in the top, 3 or 4 things. But you're right. Google and Red Hat are probably the biggest movers and shakers right now, yes. But we are planning on fixing that, not just because of what might happen in 6 months. Yes. There you go. All right, moving forward. Okay, so eventing. So eventing, you can kind of think of this as Knative is providing you the base infrastructure to set up an eventing network, basically. So, how do you subscribe to an event source to get those events into the system? How do you tell it where to route those events once they get into the system to the proper function or functions? And that's what Knative eventing is all about. So the most basic level, what you can do is you can define what I call an event source. So for example, in my demo, I'm going to create a GitHub event source, which is basically saying, subscribe to GitHub for me. I want to watch this repo for these events, and when they get sent, send it onto my service. Now, I could do that by talking to GitHub directly, right? I could set up a webhook, get my API key in there, and set all that up. But Knative now does that for me. By just creating a event source, I give it all the information that it needs, and then it will talk to GitHub for me, set it up, connect it to my service, and now I don't need to worry about it at all. So I can make this subscription process part of my normal deployment process, right? Because he was talking about Helm files for doing deployments. Stick this definition of the GitHub event source into your Helm file or your Helm template, and boom, you get it automatically deployed and subscribed for you. You don't have to set up your own bash scripts or whatever to talk to GitHub for you on that. So that's the simple case. Now what you can also do is stick into the middle there something called a channel, which you can kind of think of it as a pub sub model kind of thing, right? The event comes from source into the channel, and then you get multiple subscriptions to that, so you get this wonderful fan out thing. You could technically have a database in there, get a little persistent store for enterprise-y type stuff. But then everybody that's subscribed to that channel now gets the event, so you can get fan out. Just a little bit more of a real-world scenario there. And lastly, you can also if the service happens to reply to the event, even though technically events should be one ways, if there is a reply, you can tell it what to do with that reply. For example, send it on to yet another sync or service, or even another channel, so you can get a little recursiveness going there. Now, Knative comes with a set of canned or community-developed channels, or not channels, well, channels too, but I'm thinking event source. So things like the GitHub event source I mentioned, a cron event source for timers, a whole bunch of different services that are on the web. A lot of those are already there for you, so you can use automatically. It's very handy just to have those things set up for you as part of your normal deployment process of your services. Now again, this is changing a little. They're introducing the notion of brokers and triggers, which is actually just a layer on top of channels and subscriptions more than anything else. It's just a layer on top. It's providing another abstraction, which I have, to be honest, I don't completely understand why yet, but they keep telling me it's necessary. Where people should work with brokers and triggers later, and under the covers, they'll use channels and subscriptions to get the job done. So just be warned that when you start playing with this stuff, you'll see brokers and triggers in the documentation. But I think it's similar to this channels and subscriptions. All right, with that, let's try a demo. And if you notice, I actually didn't introduce that many things. All I really talked about was the service, the route, the configuration, the revision. Those are going to be under the coverage. My demo, for the most part, will not deal with those at all, which I think is really, really cool. Okay, so, demo time. Okay, so basically, here's the code for my application I'm going to use in the demo. It's a very simple little web application. You can see down here, I just set up the web server, handle the HP handler func to just call my stuff up here. And really all I'm going to do, it's in handle func to call this thing right here. All I'm really going to do is sleep for 500 milliseconds because that makes my demo run smoother. And then I'm going to print out a message where the message is basically here. The revision number, or the revision name, and text. Text is hello world. Revision name comes from an environment variable. Every Knative application that's deployed gets a whole bunch of environment variables, just like normal Kubernetes type stuff. Knative, in this case, inserts the revision name into there for you if for some reason you need it. So to show you guys that a new revision gets deployed, I print out the revision name. That's all it is. It's fancy stuff. Okay? So, what I'm going to do is first do this quote the easy way using the KN CLI, which is obviously a CLI developed by the Knative community. It's still very much in its infancy. So I'm going to do a simple deployment using this just to show you a sort of Cloud Foundry-ish type experience. Then I'll jump to the a little bit more complex path, which uses YAML, which actually lets you get more stuff done because KN doesn't have all the functionality. So anyway, going to do a deploy, right? KN service create -- image. So I'm pointing to the Docker image or the container image that I'm going to deploy, and I'm going to call this service hello world. And that's it. One line. Now, on the right-hand side window, what you'll see is the first section says hello world, and then down there it says hello world -- whole bunch of crap. The first section just shows the KN services that are deployed. So as I start running the demo, you can see all the services that are there, and then down below you can see the actual pods that are actually created as a result. So you'll see, okay, great, we have one pod and one Knative service, which is what you'd expect, because I just did the deploy. So, just to double check in case you didn't have the pods we were running, if you did a kube control get k service, you'll see here my one service. Its name, notice the URL, right? It already gave me a domain or URL to talk to it. So what does that mean? I can turn around and do a curl, and I get my output, right? I get hello world prefixed by some random number, which is the revision name, right? Now think about what just happened here. With one command, I deployed something into Kubernetes, set up the networking, and even though I didn't show it, technically if I bombarded this thing with a whole bunch of curls, it would automatically scale as necessary. And then when I stopped the curls, it would scale back down. And if I ramble long enough, that pod right now is going to disappear because I haven't hit it in a while, and it will get deleted. The service will stick around, but the pod itself will go away. Now I'm not going to bore you by rambling that much. So what we're going to do, actually maybe I will. Let's see. So Tom asked about all the resources and the covers. Now, this little script I wrote just to print out all the Kubernetes resources. These are all the things that are created in the system that, well, most of these anyway are actually created by my actual deployment. There's one or two in here that wasn't, where is it? These channel provisional things, those are like an empty thing, but ignore those. I think pretty much most everything else was created as a result of that one command line. So think about all the Kubernetes resources that you might have to manage to get the equivalent functionality. That to me is huge. Yes.
That I noticed that you actually curl use the like a full DNS name.
Mhm.
So how is that done? I mean, is there DNS actually service running that you map up those names with I don't know what kind of DNS entry chain or something?
Yeah, okay,
Have you
good question.
seen that?
Yep. It's magic, basically. No, actually, it's a little bit of, so I'm running this in IBM's, IBM Cloud, using the IBM Kubernetes service. And by default, with the IBM Kubernetes service, it will give you a domain name for your cluster, so you can hit it, which means it sets up the DNS stuff automatically. And it's actually a wildcard domain name, or AA record, and TLS certificate and all that other stuff. So by default, it actually gives me KN demo, which is the name of my cluster, and everything to the right automatically. So basically, all we had to do is we installed Knative on IKS, IBM Kubernetes service. All we had to do is tell the ingress that anything star.kndemo, whatever, gets routed to the Knative stuff. So it's a little bit of magic, a little bit automatic set up by IBM. A lot of providers are going to provide very similar functionality because there's no reason to force everybody to do this on themselves. It's annoying. So, yes, sir.
So I may not understand this, but did you have a cluster already set up?
Yes.
You configured your Knative?
Yeah, so so for full disclosure, before the demo, I did obviously install my Kubernetes cluster, and I installed Knative, which actually installs Istio under covers. For those of you who don't know, Istio is a networking mesh. I did install those, but I didn't do any specialized configuration of those things. It was just a generic install. And then, in preparation for the demo, I think I installed one build pack that we use later in the demo. But that's basically it. There's no other CAN configuration that you would not experience yourself, or that you would have to do yourself if you wanted to run a demo. So pretty much this is very, very vanilla.
So it's kind of follow up on the same thing.
Yeah.
The kn command that you have there, is that an API service running somewhere which is a part of Knative installation which is listening to that command, or is that a wrapper around the kubectl, or how,
Basically, KN is the equivalent of kube control. It's just hiding the YAML from you. And in fact, once we're done with this part of the demo, I'm going to start using, in essence, kube control for everything else, and you're going to see the YAML. So KN is just a wrapper for, well, it's not technically a wrapper for kube control, but it's the equivalent of doing the same REST APIs as kube control, passing the exact same YAML. There's no special service running on Kubernetes just for KN. It's calling direct Kubernetes APIs.
so Knative installation is not adding to any additional pods than whatever the kube control plane already has?
Well, okay, be careful. It's not adding new, I hate the word API, but it's the term they use. It's adding new resources to the Kubernetes model, but it's not exposing a new endpoint.
I see.
Right? So Kube you can still talk about using kube control to the exact same endpoint as kube control get pods. Right? It's just, instead of just pods, deployments, replica sets, you now have these things called K services. So we've extended the Kubernetes model with new resources, but it's the same Kubernetes infrastructure that's managing those resources that manage pods. It's just new types of resources. And obviously, when you create new resources, you have to create the controllers that manage those resources. That's part of the Knative install. So when you install Knative, you define a whole bunch of custom resource definitions, the controllers that go with them. And so yes, if I was in here somewhere to look at the pods that are running in the system, you would start seeing a whole bunch of Knative pods.
Knative pods, okay,
Yes.
got it.
Hopefully that answers your question.
Yeah,
Yeah.
definitely.
So, maybe I overheard this, but I heard you mention extensions. Does Knative install any Kubernetes extensions?
Yeah, that's what we were just talking about, the CRDs,
Okay.
custom resource definitions. In fact, if you actually look on here, anything that has Knative in it is an extension resource in the model. So obviously pods, replica sets, these services, actually I guess I sorted it, yeah. So these are the Kubernetes resources that get created under covers. These are all the resources that Knative add to the system. And these are just the resources that are used for managing, or that were created as a result of my application. These aren't the resources that Knative itself has running in the system just to manage all this stuff. Okay? I could show you when we're all done, if you remind me, I'll show you all the pods that are running in the Knative namespace. There's not that many, but there are some. Okay?
Question
Yeah.
on that, because it sounds like you go out of your way to say, look how much stuff this thing is doing for me.
Yep.
And yet it's right now running it. Granted, it's a function, but it's doing hello world with a a unique identifier. So what's the overhead of buying into Knative, and does that play well compared to the overhead of other function-based systems?
When you say what's the overhead?
Granted, probably people who want to implement Knative also buy into the Kubernetes or OpenShift as a basis for their implementation, for ease of implementation. And that's a big deal, does it compare well in terms of raw hardware utilization?
I'm not sure I'm the best person to answer that, because you're right, you have to buy into Kubernetes to begin with. Right? And there are some functions as a service, service platforms that, in essence, do their own management of containers, and so it's probably a lot more lightweight. But one of the reasons for using things like Knative is you want the benefits of Kubernetes, right? You want the ecosystem, you want the functionality, you just don't want the complexity. Right? So you're already willing to buy into having a Kubernetes cluster.
Okay.
And so that's kind of the way I look at it.
So also things like Kafka and PubSub, message passing buses and stuff like that. That's all engineered into Istio, right? So that's already there.
I'm not an Istio expert, but I know Istio does the routing and stuff. But I'm not sure it has stuff like Kafka built in. Does it? I thought.
Well, it's or it's.
I don't know. I didn't think it did.
I just googled Kafka and Knative, and it popped up as we do this.
Well, you could hook up the eventing side of Knative to Kafka queues. I know they're working on that kind of event source. I mean, that's what the link was. But I could be completely wrong. But I didn't think Istio used Kafka on the card.
No, I don't. I'm not. I'm just a complete noob, so I'm just asking.
I'm not Istio expert.
To your question, one of the points on this presentation was the system Knative is meant to reduce time to market. So the overhead is well worth the time that you save getting to market.
Sure, because setting up your own cloud and doing something, whether you buy into somebody else's function solution or you do this, costs you. So you have to. There's time to market is a big.
Right. I mean, look at how quickly I got my application deployed. If someone set up my cluster for me, installed Knative, or even I did it through one-click install, which IBM has all this stuff. One command line, my application deployed. I don't have to worry about it anymore, basically. It's just there. Yep.
So, are there any architectures that you have within your application stack that you kind of want that complication of Kubernetes to say, okay, let's, we're doing X, Y, Z with this environment, this offering. We're going to use Kubernetes for that, or I guess do you use Knative for everything, or sometimes you're like, we're doing something really.
That's a good question. So those in here, the basic question is, would I recommend Knative for everything or just certain types of applications? My personal goal is to get to the point where you can use Knative for just about everything except some really weird edge cases. The problem is Knative is being advertised by some people, in fairness, most of the community, unfortunately, as a serverless platform, which means it has some built-in requirements of how you view your application. For example, let's see if I can scroll up here. Okay, so for example, notice in my application, I start an HTTP server. A lot of serverless platforms, that's fine. But there are some serverless platforms where they say, no, you just give us your source code. I just want your little print hello world thing, right? The entire notion of a serverless function author having to write an HTTP server is something foreign, right? So you have to write your application with the assumption that it's going to be listening for some incoming event, because that's what's going to be the trigger, right? So if you want to deploy a container that isn't triggered by some external HTTP request coming in, but rather you just do a Docker run and it runs and does its stuff, this isn't a good model for you yet. Okay? Some of us wanted to do that, but as of right now, it's not a good fit for that kind of thing. If you want your application to run for a very, very long time, this may or may not be a good model for you, because if the network connection goes down, Knative thinks it's done, and it will kill it after 90 seconds, which is why my pod is no longer there. Even though the HTTP server is still running. Right? So you got to make sure you're okay with that. If you write your application in such a way that when the container is done running and it exits, you don't want anything else to happen, you want it to just go away, this isn't good for it. Because Knative will interpret container exiting as, oh, something went wrong, I need to restart it. Because its purpose in life is to keep a certain number of instances running based on what you told it. Because one of the configuration options here is, don't scale down to 0. I want at least 3 running at all time. That's fine, you can do that. But if one of those dies, it's going to restart it, right? So you have to be willing to live inside a serverless world and the constraints of what a serverless function is based upon their definition. Some of us are pushing those boundaries, because like I said, I personally do want to be able to run most things through here. Because I technically think there's no reason why I couldn't be able to say keep at least 1 running all the time, which you can do today, but I don't want it to be triggered by a HTTP connection. I want it to be triggered by just the fact that I created it, right? Or some other mechanism, right? Those are in the works or at least under discussion. Whether it happens or not, I don't know. So the short answer to your question is, if you're going to live like a serverless application, yes, it's good. If not, play around with it and see if it fits. Okay? All right, we got to move forward. But notice, like I said, it's scaled down to 0. The pod is gone. So that's great. So if I was to do another curl right away, as Derwin's question alluded to, it would take longer for the curl to come back because we need to spin up the container, then it could hit it.
Can we see it?
Later. Wait, can you see it? Hold on.
Not the real devil comes in.
Yeah, I know. Oh, I should say, you may have noticed, I'm not actually typing, I'm hitting a space bar.
Yeah.
It is live. I just have a script that does the typing for me because you don't need to see me copy and paste. Okay?
That's pretty
You're pushing my limits here. Okay, hold on a minute. Hold on. I gotta get the right machine. Actually, no, I don't. I'm sorry. I can get this for you. See, now you're going to need to open the thing. How it came up. Notice it's taking a while. Initializing, running,
Yeah.
got it. Okay, so a couple of seconds. Okay, back to the demo. Alright, so we did that with a simple way, so that's going to delete it, one command, gone. Notice not just the pod went away, but the case service as expected. So everything's vanished. Very simplistic, Cloud Foundry kind of experience. So life is good. Alright, so now let's do things the hard way, or the harder way. Not quite as hard as Kubernetes, but a little more fun. So let's play with YAML. So for those of you who know YAML, you know this is kind of ugly, but if you notice, what's actually in here? Name of my service, a whole bunch of crap, which is just get this indentation, and then the image. This tells Knative to only allow 1 request per container at a time. If you get the second request, send it to a different container, in other words, scale it up. The only reason I have that is because it makes the demo much more exciting when I throw a load at this thing. Because otherwise what's going to happen is every container will handle like 50 to 100 requests, and I got to generate 1,000 requests just to generate a whole bunch of more pods. I don't want that. So that's what that option's for. But notice, if you compare this with the original KN control, or KN command I gave, it's just 2 bits of information. Name, image. The rest of it's just noise because, you know, YAML's YAML. That also means there's more options you could technically put in there. Okay? Oh, question. Yes, sir.
Yeah. So this YAML kind of assumes that the image is already there in the registry, but this piece is missing the build process. You said there is a subscription to the build server and stuff.
Patience. I'll show you build in a second.
Okay.
I'm doing it stepwise, yes. But yes, this does assume that I have an image called Dublin/Hello World on Docker, already pre-built. Yes, we'll do the build in a second. So, kapply is just a shell script or a script I have that just does a wrapper for sending the YAML over there. I'm not going to explain why I have that, but I do. There's no tricks under there. It just makes my life easier. This demo is actually available on GitHub. If you read the documentation, you'll understand why I created kapply. Basically, think of it as the same thing as Kube control. Okay, so created the service. Notice, hey, we got a service back and a pod running. So now, if you weren't running the pods running off to the side, they just do it right here. Let's go into Kube control. You can see the same output from get services with the URL. So now I can run curl again, and boom, hello world. Basically the exact same thing as my canned demo. Still, I don't think that's bad, especially if you're coming from Kubernetes world, or even if you're coming from a Docker world. It's not horrible. YAML's not the greatest thing in the world, but it's not that bad, right? It's still something you can kind of wrap your head around, because really all you're doing is giving an image name and a service name. So that's good. All right, so let's talk about adding build. So here's another YAML file, YAML or service number 2. Exact same thing down here. So this is defining my revision. That's basically the version of my application. Same thing as before, nothing's changed here. This stuff is all new. So look, I'm defining the build section. Let's jump to some interesting things. So what I'm telling it is, I'm going to do a build. Here's my source code. I'm pointing it to this GitHub repo. So Dublin Hello World branch master. I'm going to use a build template called Knative, which I've already installed into my Knative system. And I basically just have to tell it where to store the image. So I'm going to store it back on Docker Hub in Dublin Hello World. So GitHub repo, image, this thing will magically do a build for me. Ignore trigger, we'll talk about that later. But everything else is just normal YAML indenting. This service account, that's just giving, that tells it what credentials to use to actually talk to the system, because it needs to be able to eventually talk to the rest of Kubernetes to get the job done. But for the most part, pointing to GitHub repo, image. All right, so let's go ahead and apply it. Now, the interesting thing is, Knative will look at this and say, oh, your configuration has changed. I need to deploy a new version of your application. That's the second problem. But because you now have a build section, notice the new pod here, right there, has the word pod in it. It doesn't say deployment. That's because that pod is actually my build pod. Knative kicked off a build, which is basically using this Knative container or image. It downloaded the GitHub source code into there, did the build, and then when it was done, it pushed it back up to Docker Hub under my Dublin ID, and now it did another deployment. So you can see that the pod went away, and now I have my deployment back. So if I was to do a curl, it's still running. However, let me scroll back up for a second here. Notice the revision name used to be 8Q8. Now it's QXL. So it's the exact same output, just the revision name has changed, right? So that shows the build process involved. Yes, Tom?
You mentioned the build. You use a template called the Knative.
Yep.
I didn't see where actually, how do you kick off the build? When you say Knative, does that mean you actually have some kind of build convention built in?
Right, so
You know how to kick off the build?
yeah, what you need to do, if you're going to use a build template, which is basically the equivalent of like a makefile kind of thing, right? That's going to do your build for you. You have to look at the documentation so you know what it expects, where certain files are going to live. So in this particular case, by default, it knows to look for a Docker file in the root of my GitHub repo. So it does a Docker build with the Docker file, and when it's done, is the equivalent of a Docker push to that image I gave down there. Yes.
So how does this build system work with like testing? Like if I want to run unit tests before I actually deploy this thing.
Yep. So I don't show it in here, but in this particular environment, there is a way to define multiple steps in there. And one of the steps could actually be a test step before it gets pushed up to your production system. Okay. I'm going to talk a little bit more about build later because there are major changes going on here. But this covers the basics of it. It's basically you define a step. The step means run a container. You tell it what inputs to the container it needs to get its job done. And then when that works successfully, you move on to the next step. When the steps are done, as long as it's part of this system, Knative will deploy a new version of your application, meaning a revision of your service. Yes?
So is this gonna replace the traditional continuous integration stuff, or what's the,
I'll answer half your question. No. this is too simplistic. I'll say where there's another answer later on where the answer would be yes, but not this. So wait a little bit.
That's too simple, as far as I
Yeah,
see, but
this is
in
very
general,
simplistic.
I'm asking.
Yeah, I mean, technically, you can put whatever you want in that build step, right? You can replace Knative with your own container that does the entire Jenkins job, right? You can do whatever you want in there. It's just people like this because this notion of, well, maybe here's this. Like I mentioned earlier, a lot of serverless platforms like the notion of give us your source code, we'll put it into our container for you, or we'll compile it for you, and then host it. That's what this was trying to replicate, basically.
So the source to image concept.
Yes, basically that's what it was trying to do.
Okay.
And, fine, I'm getting ahead of myself, but like I said, this is a little too simplistic. People don't also like the fact that this links build with serving. They want more of a separation of concerns, right? So for example, what if you liked this for build, but you don't want to necessarily use Knative for the deployment side of it? Well, how do you extract this, right? Oh, now you got to figure out how to use Knative by yourself kind of thing. So there's a whole bunch of reasons why this isn't the right solution, and we'll get to what I think the right solution will be in the future. But just hold on a little bit. Okay? All right, where are we? Okay, yeah, same happened as before, just different revision now. But we added build. So, let's go back to the slides just for a second, because we're going to add something even cooler to the system. All right, so this is an architecture picture of what we actually have deployed that you don't need to worry about, right? But it has all everything we talked about, right? We have the Knative service, we have the configuration, which just manages the revisions, you have your route that does the routing for incoming requests, we got your build pointing to your definition, which kicks off a builder pod, which pulls images from the GitHub or the Docker Hub repo, which can then get used to deploy your application, which are your pods. You've got your Istio gateway in there, which manages the curl command and sends it to the right revision. Life is all good, very complicated under the covers, but you don't need to worry about that because all you had to do was deploy a single YAML file. Perfect. Now, this is all wonderful, but I didn't demo eventing. So let's demo eventing, let's add eventing to the picture here. So what we're going to do is we're going to figure out some way to make it so that when I change my source code on GitHub, it kicks off another build automatically. In order to do that, there are a couple things I need to deploy alongside. Now, I'll admit this is getting a little more complicated than I would like to be, and I'm hoping they simplify it. But hopefully you'll realize that all I'm really doing is, for the most part, is deploying things that I already know. Like in particular, I'm going to deploy a rebuild service, which is nothing more than yet another Knative service. And an event source, event source which connects up to GitHub for me. We'll talk about that as we go. So, first I need a rebuild service, which, when invoked, or curled, does nothing more than takes, or that goes to my Knative service and tweaks its configuration in some way. Because remember what I talked about earlier is when I did that deploy of service to.yaml, I didn't actually change my service at all. All I did is add the build definition to it. Well, Knative interpreted that as a change. It doesn't know what kind of change it was, so it says, oh, it's a change, I need to redeploy this thing. And now I just have another build. Well, the rebuild service is going to do nothing more than go get the configuration of my Knative service, my hello world in this case, modify the configuration in some way that doesn't really have any real meaning, which is that trigger flag I showed you right there. We'll revisit that in a second. And just change its value. Reapply it, and Knative will notice a change. Doesn't matter whether it's a significant change or not, but it will now force it to go get the new version of the image and redeploy it out into my system. So we'll do that upgrade for me. That's great. Now, we need something that hooks my rebuild service though. Well, that's that GitHub event source I talked about earlier, right? So when I create a GitHub event source, I say point to the Dublin/Hello World GitHub repo and make my rebuild service the quote sync of that GitHub source. Meaning as events come in from GitHub, they go to the GitHub event source first, and it just routes it to a rebuild service. The fact that it got called is what's going to kick off the build. And finally, of course, not getting actually created obviously, but we're connecting up the GitHub event source to GitHub repo. And that's what the GitHub event source does for me automatically. And finally, the initial thing that kicks off this whole big process is I do a push to GitHub to make a code change. Okay, so this is going to get that automated CI/CD build process in place by just making a change in my GitHub repo. As a developer, I don't need to do anything once it's set up. As I make changes, it's built, it's put it through Docker Hub, automatically deploy to the system, and the system will roll out a new version with 0 downtime. Okay? So, let's keep going with the demo. Yes, sir.
You said 0 downtime. How does that system achieve 0 downtime?
It won't take away the old one, so the new one's up and ready. Easy answer.
Well, and it will do blue-green too, or not?
So the way I have this set up, it does not have any smarts to say, oh, the new one is up and running, and it's actually responding properly. It doesn't do that. It just says, from a Kubernetes perspective, the pod is in a state of running. That's all it knows, and that's good enough for it to start killing off the old ones. Okay? Yes?
So does it not have its own like health check you can add in or something to keep the blue-green to actually preventing from failing on turnover, or?
Yeah, so I'm trying to remember, because I haven't played with that part of it myself. I don't believe there's something built into Knative yet to leverage the Kubernetes health check type stuff. I don't think that's there hooked in yet. I think it's probably under discussion now. I could be wrong, but I don't think it's there yet. At least in the documentation stuff and the stuff I've seen in terms of code-wise, I haven't seen it. Okay? I could be wrong. But not in every bit of every line of code. All right, moving forward. So let's go ahead and first deploy that rebuild function or service. And here it is. It's just a normal Knative service, calling it rebuild. I put this on Docker Hub in advance. I believe the source code is part of my repo. You can see it. It really is nothing more than gets an event, make sure that the event from GitHub is a push. And if so, it will go find this this Kubernetes service, Knative service that I have deployed, grab its YAML, twiddle it slightly, put it back in there. So I just need to point it to my Docker image and what service to twiddle when the event comes in. That's really it, not a whole lot there. So, but I need to deploy it to the system. So what you're going to see is, I now have 2 services running, Hello World and Rebuild, and because I just deployed it, it will actually start up an instance of it ready, waiting for events to come in. So now let's go ahead and deploy my GitHub event source. Now this has everything we actually talked about before, right? Points to the GitHub repo. I'm going to have to pass in some secrets so it knows how to set up the webhooks for GitHub, and then tell it to sync, which is basically where to send the event once it comes in. So it's going to do all the subscribing and management of GitHub webhooks for me automatically. Let's go ahead and deploy that. Okay, and this actually is a service as well, because this is going to be receiving incoming HTTP requests or events from GitHub. So this itself is a service, not just a subscription mechanism. So kind of eating your own dog food here. All right, let's go ahead and edit our application. So, this is why I have script. Yes, okay, so I edited it. Let's go and do the git add, git commit, and let's do a push. Now, if everything works, what you should see eventually over here is a pod pop up, which is going to be doing the build. And okay, so you got it. I think you get it in source. Okay, well it takes. Oh, the middle one. I'm sorry, it is a pod. Okay. So while we're waiting for that build to happen, because it takes maybe 20 seconds or so, well, I'm also going to do a curl command down here so you actually see the 0 downtime. I think there's like a sleep of 5 seconds between each one. But notice that trigger right here. That trigger 15 is what my rebuild service is going to modify. Later on, if I think about it, I'll get the output or the YAML definition of my service, and you'll see the trigger will have changed from 15 to some other value because my KN service, my rebuild service, would have twiddled that for me. But it didn't change anything else in there. It's just the fact that thing changed forced this thing to do a rebuild. So notice zero downtime, but now I get the new output because it's deployed another version of my service. Now notice, however, I actually have 2 different deployments of Hello World out there, one old and one new. That's fine. Eventually, they will both die off. Hopefully, the older one first. All right. So now let's go ahead and do a little bit of A/B testing. Now this is doing what I call very sort of dumb A/B testing, but it's what I described in my charts earlier, which is I'm going to have, I think, like 90% going to one version of the service, 10% going to the next version of the service, and the routing happens automatically under the covers for me. But you can see most of this stuff, I'm going to do is a kube control patch by service definition. But you can see most of the stuff that I'm patching here is the exact same as before, right? The revision templates, the build stuff. What's changed are those two lines right there, the revisions and the rollout percentage. The revisions basically say, here are the two revisions at play. I want 10% to go to the new one, 90% to go to the existing one. Where the new one is what I'm defining basically down here. And because the configuration actually hasn't changed, it won't do a rebuild. It says, oh, I already have that guy. I don't have to do a rebuild, I'll just deploy it. So let's go ahead and apply this. And what we're going to now do is generate a load. For 30 seconds, I'm going to generate 10 constant curls to that URL. And what you should hopefully see is of the 10 different curls or clients that are running, about 10%, or 1 out of 10, should hopefully say hello world, and the rest should say cat's drool. Come on, say hello world somewhere. There we go, hello world, it pops up here now. So about 10%. It's not perfect, but it's rough. Okay? So the reason I think this is a little bit simplistic and I'm not particularly thrilled with this is because I'm not sure in the real world you'd ever really want to deploy or have your customers randomly hit one version and then randomly hit the other version next time through. Usually you'd want to have like a beta tester group or something. Somebody that said, I'm going to be a sacrificial lamb and hit the new version, and therefore I'm okay hitting that, but everybody else needs stability, right? So I think eventually they're going to have some sort of smarter routing that says, sure, some go to someplace, some go someplace else, but not based upon a random percentage, rather based upon something about the user hitting the system. But this is what they have right now. We're working on the other stuff. All right, so now let's actually show all the resources that were created. And luckily, we still have all 10 instances of our pod running. Oh, and I should mention, notice it's scaled up, which is kind of cool. So look at all these resources that have now been created, right? That's a nice size list, right? So you have the normal Kubernetes stuff. So you've got your deployments, endpoints, pods, replica sets, Kubernetes services. Then you got the Knative stuff down below here, right? Lots of things to manage. I didn't have to manage any of that myself. Right? The system did it all for me. And notice, I only had to touch a single YAML file, basically, for all this stuff. Right? I don't have to have a whole bunch of different resources at play, just the service definition itself. Anyway, so that's the demo. Got it work. Oh, here, there you are. Okay, I apologize. If you want to go, I won't be offended. I know we're anywhere. All right. Let's see where we talk about that. All right, so basically, what did we do? Obviously, we deployed without build, we deployed with build, we did rolling upgrades, we integrated to webhooks, to GitHub. I guess I did lie a little. There was some other YAML files, but we actually did the hookup, right? Because we had to do the rebuild service and the GitHub event source. But in terms of the service itself, single YAML file, which I thought was really, really cool. What didn't we do? Well, all the stuff you normally would have to manage under Kubernetes yourself. Okay? Demo is available at Dublin/Hello World if you want to actually play with it. The README in there goes through lots of excruciating detail because I rambled a lot in there. A lot of what I'm talking about here, but I also tried to talk about what happens under the covers and even some mistakes I made while writing this, so you can hopefully not make the same mistakes I did. So, for the most part, that's pretty much it in terms of Kube. Hope you'll realize there actually isn't a whole lot to it because it does so much for you under the covers, but it tries to prevent the simplified user interface or interface for you. But what exactly is Knative, right? Is it a service framework? Is it a PaaS? Is it just a new way to talk to Kube, which is what we were talking about earlier, right? I want it to be. I would love it if this could become the way to talk to Kubernetes, except for the 1 to 5% cases out there for deploying applications, but we're not there yet, right? It doesn't really matter to me what you choose to call this thing, right? A lot of people like to call it serverless, some people call it a platform as a service. Think about the functionality and whether it meets your needs, and if it works, use it. If it doesn't, fine. Drop down to Kubernetes, go back to Docker, doesn't matter. Only use technology that actually works for you to get your job done. Don't pick this up just because it's the new hot thing. It does have its limitations, so make sure it meets your needs. Don't try to force fit it into your environment. A couple of notes as you start playing with it, if you do play with it. They are planning on supporting the pod spec in there. And what I mean by that is, a lot of the things we talked about there look a lot like a pod spec, right? You have your image name, you can set up memory constraints, you can mount volumes, do environment variables. And rather than inventing a new YAML syntax, they decided to use the same syntax as a pod, even though it's slightly more complicated than we might want to do if we're starting from scratch. But at least that then gives you the possibility of migrating back and forth between Kubernetes and Knative relatively easily, right? Copy and paste for your pod definition if you want to, just for a little bit of consistency for people. It does leverage Istio for networking, but it is optional. If Istio is too heavyweight for you, you don't have to use it. I did mention KN. That is the current, or as one of several KN or Knative CLIs that are out there. I suspect it will be the winner in terms of popularity because that's the one being developed by the community itself. Notice I did talk about configs, revisions, and routes under the covers, but notice I didn't use them. A lot of people who play with Knative like to deal with configs, revisions, and routes themselves under the covers manually. And you can if you want to get dirty. My goal is to make it so you only need to deal with the service object. And there are some changes coming in the next version of Knative which pushes you even closer to that direction. So the rest of the community, for the most part, is agreeing with my point of view, which is service should be all you need. The fact that the other three are there should not matter to you as an end user. Okay, now to the other question about whether the build stuff in there is going to be a new CI/CD pipeline type stuff. No. The KN build stuff is probably going to go away. It's not 100% sure yet, but it's really, really close to making that decision. Mainly for what I talked about earlier. It's pretty much too simplistic. People want a more real CI/CD system, like maybe Jenkins kind of environment, just to be able to configure. And people don't like the fact that KN build and serving were tightly bound together. They want a little bit of separation. So what they did is, a while ago, they took KN build and used that as a starting point to build a new project called Tekton, Tekton. And along with two other projects, Spinnaker and Jenkins X, I believe, they started a new foundation called cd.foundation, which is under the Linux Foundation. And it's basically a foundation for CI/CD pipeline type stuff. And Tekton is meant to be what you saw so far with KN build, but on steroids. Now hopefully they'll keep the simple use cases simple, so you can take that same YAML I described here for your build section and do something very simplistic like that with Tekton. But you can also get into more advanced stuff where you have multiple steps and do more complicated things. In all honesty, I haven't played with it yet, so I don't know whether they're going to succeed. But I know from some people within IBM who are very much on the CI/CD pipeline type of world, they're very excited about Tekton. They love it. They're looking at it as a replacement for Jenkins. So they're very, very excited about it. So take a look at it. It will probably replace KN build as the preferred choice for KN services. Okay. Since I'm an IBMer, quick little plug for IBM. On the IBM Kubernetes service, we do have Knative as a single click install. Basically, you say I want Knative, you get this thing, just hit install. Literally one click and it gets installed for you automatically. Sets up the networking stuff for you, sets up Istio for you. No other things. Once that button is run and it can get deployed, you can immediately do your kube control apply for your service and then curl and you're done. Really, really cool. Some links to the Knative docs. IKS for IBM, because I'm an IBMer, and then the hello world for the demo itself in Rangers. And I apologize for running way over, but there's really good questions. I could blame you. Any other questions? Yes, sir.
Yeah, I'm just curious as to how IBM's Cloud Kubernetes service compares to the other services out there, such as all the other cloud ones, EKS, AKS, what about Pivotal, what about OpenShift?
We are the premier best Kubernetes provider out there. What do you want me to say? I mean,
Right, this is open
obviously,
forum, right?
yeah, I mean, no. Obviously, Kubernetes is Kubernetes, so they all should be portable. They're all going to be conformant to the Kubernetes conformance suite, whatever you want to call it. So, from a straight functional perspective, they're all Kubernetes. Each one may have its own little special sauce to it. Some may be faster in some areas, others. Some may offer different types of volume storage, stuff like that. Really need to look at each one to see whether it suits your needs. But at the most basic level, Kubernetes is Kubernetes. Obviously, I like ours because I use it. I've used a couple of the other ones. I think ours is actually one of the more easier ones to use. For example, I know we set up Knative stuff automatically for you. Other ones require you to do the Istio or networking stuff manually, set up your certs and stuff. We do it all for you. So I'm biased, but I like this stuff.
I guess you still got one free cluster, right?
Yeah.
Just to play
Well,
with it if you want.
well, okay, in fairness, you do get a free cluster if you go to IBM, but it's too small to run Knative.
Just to play with it.
I know, I just don't want to be walking, don't like your lights.
Is that for free, right?
Yeah, you can get Knative for free, but you need a cluster with 3 worker nodes. Because the pods that are running, in order to run Knative, eat up enough space that the free cluster isn't big enough for it, in all honesty. So, but I think you had a question back there?
What does Knative have over top of something like Kubeless then?
On top of Kubeless?
Yeah.
So, okay, 2 answers. One is, I haven't played with enough of the other Kubernetes-based serverless frameworks to know the real answer. The only answer I could give you is, this one is being done by the Kubernetes community, in my opinion, right? I think this is going to be more real, because it has all the key players behind it. I know Kubeless and the other ones do have some of the players. I think this has more momentum behind it, to be honest. That's one answer I can give you, because I haven't actually played with the other ones, so I can't compare from a feature perspective. Yes.
So maybe it's just me, but it feels like every year there's more layers. Are you guys looking at ways of like removing some of those layers and making things simpler?
Well, to make sure I answer the question correctly, when you say more layers, can you give me some examples of some of the layers you're thinking?
So we started with, with just pure Docker, right? People had Swarm, then added Kubernetes, now Istio on top of Kubernetes, now you put Knative on top of Istio, and then you have so many layers, right?
Okay.
And then there's OS, virtualization, and all that stuff.
Okay, so you gotta be a little careful though, right? Because some of those things aren't necessarily layers as much as add-ons, right? I don't think of Istio as a layer. Istio is an add-on to your thing. So to me, I don't consider, I guess I was gonna say I don't consider Docker a layer because Docker isn't in the picture. But that's not accurate because we have containerd with run C under the covers, which came from Docker, right? So you are right, we have run C, we have Docker, right? And we have run C, containerd, Kubernetes, now we have Knative, right? I don't know what to say other than you needed those layers to give you the automation and machine management for you to some extent, right? I mean, you need Kubernetes there because it offers up an abstraction layer on top of networking, so you don't have to get down to the networking IP table gorp yourself on Mac, right? But then there's a realization that it's too complicated, so Knative came along. So it's like you went from really simple with Docker to complicated and back down. I'm hoping that, I can't say Knative will be the end of the pipeline for layers, but I'm hoping it's near the end, because I'm not sure how you can get much more simple than, here's my container, go run it for me. Now, obviously, I guess I'm lying already. There will be layers because there's going to be tooling on top that says, I don't really want to deal with containers, I just want to hand you my source code, right? But I'm not, would you think of that as a layer or a tooling on the side to get your job done, kind of like Istio is tooling to get your job done? I don't know, it's up to you. And I don't know how to answer your question because it's all speculation. But I think this is a huge step in the right direction, and I do think it's getting closer to the true end goal, which is a developer just gives us their code and we run it.
It sounds like a great management tool, but on the point of layers, you still need to know what Kubernetes is and all the other parts to use Knative, right? You can't just come in as a novice and just know Knative as an
So
expert.
for my demo, I showed Kubernetes that I worked with Kubernetes. I
So
did.
you could come in not knowing any Kubernetes and be able to, you would still.
Well, let's be clear. It depends on what you want to do, right? If all you want to do is say, deploy my container to the system, you have to know a little bit of YAML. So you can copy and paste someone else's YAML, replace the image name, service name, and go. You don't technically need to know Kubernetes under the covers, right? Or you could use the kn command, which even exposes YAML to you. So in the most basic case, I don't think you have to even know Kubernetes is running. Now, that's just to get up and running. If it starts dying, and you want to start debugging stuff, then yes, you maybe need to find the pod, look at the logs for the pod. That's not necessarily a nice experience, but maybe, and I hope, kn will hide that from you. So you should be able to say kn, logs, hello world, and maybe which revision number or something like that, right? So you can hide some of that for you. But for the most part, I didn't deal with Kubernetes there, right? I showed it to you because I wanted you guys to see what was under the covers, but I didn't talk to it much. I think that's the goal for most of the stuff, is hiding it from you. That's the hope. Yes, sir.
So what do you view the relationship between Knative and IBM Cloud Function? Do you see them like one replace another or coexist?
Oh, you're going to get in trouble. No. So IBM Cloud Functions trying to figure out what I can legally say. So IBM Cloud Functions will be rebased on Knative. You can expect that there will be IBM stuff that goes on top of it, because stuff that was in IBM Cloud Functions, which was OpenWhisk based, that isn't part of Knative, we're not going to obviously want to drop that functionality. So we'll layer that on top of Knative. But you can expect IBM Cloud Functions to be rebased on Knative. Whether you see Knative under the covers or you get the current user experience, that I can't comment on yet. But we are rebasing on top of Knative. That's all I can say about that. Any other questions? Yes, sir.
Where did your QA process fit into that release? So like, if we're looking at going to something like this with a fully automated pipeline, but we're like, well, how do we control what versions we actually roll out?
Right, I think that relates to, someone asked an earlier question, right? Can that build stuff be used for CI/CD pipeline testing and stuff like that? Technically, yes. Today's Knative build, you can have multiple steps. One of the steps can be testing, and then you can do deployment. Exact same thing with Tecton. So I would immediately start looking at Tecton, look at the, I can't remember the terminology, they have jobs and job, I can't remember the resource names, but they have basically the notion of defining a whole series of steps. And one of the steps can be build, test, deploy, and multiples of those as you go along. It's as many as you need to get the job done.
Going back to the worker nodes, you said that Knative needs 3 worker nodes. Is that on top of whatever else your application might need from that cluster?
Yeah, in my experience, and it could be because maybe I deployed worker nodes that were too small, but I think they were like 16 gig and something like that. Yeah, in my experience, you probably need at least 3 worker nodes for the Knative stuff. That's enough for all the demos that I've run. My test environments are always running with 3 worker nodes, and that deploys quite a few Knative services out there, so it runs just fine. I think if you actually start running other applications that are bigger, that are quote real, not just demos like this, yeah, I think you will need more worker nodes to do those. One thing I will point out, one of the other advantages of Knative, to me anyway, is that because it's based on Kubernetes, not everything you deploy is necessarily going to be a Knative service, right? Because we talked about how it's not part of everything. So you can deploy normal Kubernetes stuff, and because Knative leverages Kubernetes and covers, they can talk to one another, they can leverage the same resources as if they were just normal pods, right? They can share volumes. They're still just Kubernetes pods under the covers. So whatever you do with normal Kubernetes pods, hopefully you should be able to do with Kubernetes resources and get the same sort of synergy between your application. And it's just one having to be deployed through a normal pod deployment or deployment versus a KN service. That's just sort of icing on the cake. Under the covers, it's still just Kubernetes. So I think that's actually an advantage. So you can bounce back and forth between different parts of your application. Okay? Yes, ma'am.
So you've mentioned a couple of times that you haven't really messed with the other options that are out there.
Yeah.
And I'm probably duplicating it again, but like OpenFAS and OpenWhisk are the ones that I looked at in Knative, and when I deployed Knative, the memory footprint profile of Knative was around 15 gigabytes, and the others were in terms of megabytes. And that scared me off immediately. Do you think that's like totally reasonable, or?
So that
And are
goes,
you seeing the same thing?
no, well, obviously I'm seeing the same thing because I said the free cluster won't work, right? You have to have a worker node, and our free cluster has more than, I only have 1 worker node, I mean. Whether that's reasonable or not, probably not. I don't know what to say about it though. So let me put it this way. There is some work going on to see if we can address that. One of the interesting things that I've seen someone recently play with, and I thought this was really, really cool, is part of that footprint is the fact that there's a whole bunch of pods running on the system, right? The controllers that manage these new resources. Well, those pods or controllers are running all the time because they need to look for, or they need to get events from Knative or Kubernetes watching etcd as resources change in etcd, right? Well, those are just events. Why aren't those controllers KN services? So those controllers only actually wake up when there's a change to the Kubernetes environment. So that could save your footprint. Now, granted, if everything starts getting flooded and you start creating a bunch of KN services or things start happening in the environment, they'll split up and your footprint will get really large, but then eventually it'll shrink back down. That's one option I've seen people play with. And I thought that was really cool because it's eat your own dog food, right? Use KN to host KN. Be really cool. So there are things going on. People are aware of the problem. The biggest complaint I've actually heard is that people can't run this on Docker desktop because it's too small. It's a sore point. People are wanting to look at it. I just haven't seen any progress on it yet. So, but it is in the works, hopefully.
Yeah, one of the things I'm tasked with is trying to find ways to reduce cost of our cloud.
Yeah.
And that's what killed it for me at least. And the reason why I wanted to use Knative was this zero scaling feature.
Yeah. I feel your pain. Sorry. I don't know. It's a known issue. I don't know. I mean, to me, Kubernetes in general is kind of a dog, to be honest. So, you know, people kind of expect it to some extent, but I agree. It's a bit much of a dog, and I think Istio actually contributes to that to some extent as well. And I think that's one of the reasons why people wanted to make Istio optional. Because I actually saw a report just today where someone talked about the resource utilization of Istio versus, what's the other one right there? Yeah, Linkerd. I think it was Linkerd. And they compared the two, and it was like Istio was like 350 times more resource utilization, something like that. So maybe the problem isn't Knative as much as it is Istio. I don't know. But between the two of them, you got a problem, and it's a known issue. So watch this space.
Yeah, are there any papers or anybody that's working on like the things that I'm worried about is doing it at like hundreds of services scale, and usually the things that you look at in the samples that are out there, you're looking at things that are max out maybe at 30, right? And so like I have a fear of leaning into something like this, doing the work to spin it up for my hundreds of services, and then finding out, oh well, that's going to have a crazy memory footprint.
Well, if you think about it, as you scale up either the number of number of services, or even if the number of instances of your services scales up, the footprint of the KN control plane should not change. So that means that should remain static. Now, obviously, then you have the footprint of the application scaling, which you should expect, obviously. What I don't know, this goes back to me not being an Istio expert, is whether Istio can handle the load of 1,000 instances of application running and 1,000 requests from 1,000 customers coming in, whether the load balancers can handle that. I think that is a separate problem outside, because you're going to have that exact same problem regardless of whether Knative is in the picture or not. But at least the Knative control plane should not have a scaling problem because it doesn't scale. There's nothing new, there should be no new pods running, I believe. Because it shouldn't, right? I mean, at least I don't think it does. I'll have to play with it, but I'm pretty sure it doesn't need to scale up because it's your application scales up. Anyway, that's it. You're out of time. Thank you guys very much.